It has long been proven that the average person needs periodic intellectual stimulation. That's why extreme and mystical places, abundant on Earth, are popular. However, this selection will bypass this well-trodden topic. We will fearlessly gaze into the cosmic void, where far more unimaginable objects lurk. Are you sure that Libya's Al-Azaziyah, with its plus 60 degrees Celsius in the shade, is the hottest possible place? That's a misconception. The universe contains stars far hotter, and we'll journey to them now. The Danakil Depression is considered one of the most dangerous deserts on Earth, but what about a universal ranking? The top spot rightfully belongs to the celestial body we'll discuss in this review. Are you drawn to gigantic man-made and natural structures? The Great Pyramids, the Burj Khalifa, Mount Everest? We'll show you truly impressive scales. How about a star 5 billion times the volume of the Sun? We guarantee you'll see it today. Do you complain about the difficulty of observing bright objects without dark lenses? The universe houses stars whose rays are 340,000 times more intense than the Sun's. No glasses will save you from them. It's no secret that Earth abounds with places where terror resides eternally. Consider the deadly Brazilian Ilha de Queimada Grande, teeming with venomous snakes, or the Italian plague burial grounds, rumored to be the prototype for the film Shutter Island. But even more inexplicable horror lurks in the impenetrable cosmic thickets. Meet Dark Star, a clump of dark matter wandering on the outskirts of the Oikoumene, painfully reminiscent of a mystical death star. Everyone knows that the most powerful magnet on Earth was created at the Los Alamos National Laboratory. It's 2 million times stronger than our planet's magnetic field. But these are child's play compared to a magnetar, a magnetic trap whose gram of matter reaches a mass of 100 million tons. We will soon get acquainted with this cosmic monster up close. This is far from all you'll see in the video, so get comfortable. The journey promises to be long and exciting. Comparing the universe to an ocean isn't entirely accurate due to incommensurable sizes, but it's the only description accessible to the human mind of just how vast it is. In the cold, silent cosmic ocean, numerous inhabitants reside. Stars shining like monstrous lamps, planets of various sizes, and asteroid swarms. But let's try to touch on a topic that excites the imagination: hypergiant stars. They exist, however much we might overuse superlatives and words like infinite and boundless. Even stars have boundaries and limits. Hypergiants' mass and size are close to critical, and their lives are very short. By universal standards, it's literally instantaneous, a few thousand, or at most a couple of million years. For comparison, a main sequence star, to which our Sun belongs, lives about 10 billion years. Any hypergiant is several times more massive than known stars, even supergiants like Rigel or Betelgeuse. Its mass can range from 100 to 250 solar masses. As for size, the largest known hypergiant star to date contains over 1,700 solar radii. The luminosity of hypergiants is no less impressive, reaching 500,000 solar luminosities, and the temperature of these monsters can reach 35,000 Kelvin. It's worth noting that such stars are quite rare. For instance, there are no more than a dozen in the Milky Way. These shining behemoths spend their entire lives balancing on the edge of extreme instability. Their interiors are scorched by a hot core, and their exteriors are ironed by gravity, so one can't envy a hypergiant. But their death is spectacular, a stunning supernova explosion and transition into an entirely different class of cosmic deities: black holes. UY Scuti deserves special attention. It's the largest known star and also a leader in mass. R136a1 holds the top spot in terms of brightness and luminosity. It's a colossal star located 9,500 light-years away. It's 340,000 times brighter than the Sun, and its radius during its pulsation period is 2,000 solar radii. To understand its titanic scale, let's use a visual example. To circumnavigate this star at the speed of light would take 8 hours, and 5 years at the speed of the International Space Station. To remotely imagine its size, picture Earth as a buckwheat groat, the Sun as a ripe watermelon. If you placed our 136a1 inside the solar system, it would engulf all the planets, including Saturn. During the study of this hypergiant, scientists encountered an interesting aspect. With such enormous size, The star's mass is only 7 times greater than the sun's, indicating its extremely low density, 1,000,000 times less than air. Even our sun's density is 1.5 times greater than water, not to mention the superdense matter of neutron stars. Simply put, its density is slightly more than that of a perfect vacuum. It's believed that the star is literally on its last breath, although who knows? Perhaps we are only observing echoes of its existence, while a titanic black hole now successfully warps space where the hypergiant used to be. The next leader, in terms of mass and luminosity, is R136a1. This star is located in a neighboring galaxy called the Large Magellanic Cloud, 163,000 light-years from us. It's almost 9 million times brighter than the Sun. If there were planets around R136a1, the habitable zone would be 3,000 astronomical units from it. However, life on such planets would still be impossible due to powerful ultraviolet radiation. If this giant star were located 10 parsecs from us, it would still look menacing on the Earth's horizon, about half the size of the Moon. And if someone were to replace our Sun with it, the star's brightness would be 100,000 times higher, and its apparent size in our sky would be twice that of our Sun. To understand the scale of the disaster according to this scenario, remember that if the Sun changed its radiation intensity by just 1/10, life would remain only at the Earth's poles. A 40% increase would make our planet a twin of Venus. Our 136a1 contains 256 solar masses and is 22,000 times larger than our Sun. But with such intense radiation and monstrous mass, the star is extremely unstable. The giant is literally tearing itself apart from the inside, which manifests as periodic explosions, and its death will be truly epic. It will surpass all previous supernova explosions. The blast would be visible even from Earth, despite the incredible distance. Fortunately, it's too far away. Otherwise, our planet would face a second Ordovician, Silurian extinction event, which was most likely caused by a supernova explosion 6,000 light-years from the solar system. What do we know about stars? These objects are visible every night. One only needs to look up at the sky. The daytime horizon of Earth is also not empty. It's adorned by a yellow, shining ball called the sun. Modern humanity is so accustomed to the sparkling points in the sky that it perceives them as something ordinary and not worthy of attention. Meanwhile, stars are not fully understood and are, in many ways, unique cosmic furnaces of terrifying sizes, fueled by thermonuclear reactions. There are billions of them, and each is remarkable in its own way. For centuries, stories, songs, and legends have been composed about stars. Sailors and travelers have oriented themselves by constellations since ancient times. Since antiquity, people have understood that life without them is impossible. Have you ever heard the oxymorons, hot ice or sweet poison? We can safely add another, cold star. Now let's slightly change established associations and move away from the idea that a star is necessarily a huge, incredibly hot torch. After all, not everything in the world fits into standard schemes. Since the advent of astronomy, its adepts have had an irresistible passion for classification of everything, including all cosmic objects ever discovered by scientists. Stars were no exception. At the beginning of the 20th century, they were plotted on a special diagram showing their various characteristics, spectral class, luminosity, and so on. Among the many participants in this diagram, main sequence stars, to which our Sun belongs, are the most studied. They are located on a scale whose background is presented as a color spectrum. It shows the entire stellar population of this type, from bluish-white stars to orange-red giants. Many stars in the universe are at this stage of evolution, but not all. For example, celestial bodies have been found that stand apart and, until recently, were considered only hypothetically possible. Their existence is now proven, so it's worth shedding light on this type in more detail. We're talking about brown dwarfs. These are a kind of failed stars, weighing up to 7% of the Sun's mass, or up to 80 Jupiter masses. Their entire life cycle is a gradual and inevitable cooling with a slow fading of stellar functions. The existence of brown dwarfs, like main sequence stars, is sustained by internal thermonuclear reactions, involving the continuous burning of hydrogen and then helium. However, the heat emission of these unusual objects is minimal. It is among them that scientists find celestial bodies that fall under the contradictory concept mentioned at the beginning of the video: cold stars. This is not just a figurative expression. Such objects do exist. But to what extent can the coldness of stars go? First and foremost, these are still stars. The standard temperature range for red dwarfs varies from 300 to 3000 Kelvin, or 27 to 2700 degrees Celsius. Yes, you heard correctly. The lower temperature limit is plus 30 degrees Celsius, colder than your freshly brewed tea. Later, it turned out that this information requires significant clarification and correction. As soon as such objects began to be discovered en masse, astronomers immediately began to classify them by size, weight, luminosity, and other parameters. But in this discussion, we are interested exclusively in the spectral class of ultracool brown dwarfs, type Y dwarfs. The latter was only recently modeled, and for a long time belonged to theoretical studies. Today's agenda features three contenders for the title of the coldest star in the universe: brown dwarfs. Let's start with the bronze medalist, CFBD's J1458 plus 10b. This brown dwarf, approximately 615 Jupiter radii in size, was discovered in 2010 by a telescope on the Hawaiian volcano Mauna Kea. This object, part of a binary star system, is located in the Boötes constellation, 100.4 light-years away from us. Its discovery caused a storm of bewilderment and excitement in the scientific world, as the star's temperature was recorded at only 100 degrees Celsius, the boiling point of water. For almost a year, this brown dwarf held the lead as the faintest and coldest star in the observable universe, but in 2011, it lost this honorary status. WYS 1828 plus 2650 takes second place in our impromptu ranking. This brown dwarf is located in the Lyra constellation, about 47 light-years from the Sun. The powerful WYS telescope helped discover this unique object. WYS 1828 plus 2650 has a temperature range whose lower boundary falls below zero, from -23 to plus 127 degrees Celsius. It shares the well-deserved silver medal with another cooling star, WYS J1541-2250, located about 18.6 light-years from Earth. This Jupiter-sized brown dwarf, much more massive than our gas giant, boasts an average surface temperature of about plus 70 degrees Celsius. WYS 0855-0714 is currently the absolute gold medalist. This brown dwarf, located 7.3 light-years from the solar system in the Hydra constellation, was discovered in 2014, and no object has yet challenged its primacy. Some scientists consider it an orphan planet. Its mass is 10 Jupiter masses, making it the lightest dwarf in our immediate vicinity. Its age is about 10 billion years, and its effective temperature is -30 degrees Celsius. The overall range is from -13 to -43 degrees Celsius. Scientists continue to study these objects, which has led to remarkable details. For example, astronomers at the University of Edinburgh, studying the atmospheric layers of these failed stars, discovered a 100-kilometer thick layer with a constant temperature of -23 to -73 degrees Celsius. Experts believe that organic life could have arisen in this location if not for infrared observations. These cold, very faint objects would never have been seen even with the most powerful telescopes. Moreover, when scientists first discovered brown dwarfs, they mistook them for very distant stars. Astronomers simply couldn't believe that such a nearby star could be so inefficient and faint. Despite their low luminosity, the existence of these stars suggests that the habitable zone of brown dwarfs could potentially harbor exoplanets with suitable conditions for the emergence of the simplest life forms. But it's not that simple. The problem lies in the gradual reduction of the conditionally habitable region due to the cooling of the parent star. Since such planets must be much closer to their dying star than we are to the Sun, years on them would fly by in a matter of days. Astronomers have also calculated the approximate period that a distant planet in a brown dwarf system can remain in the habitable zone, 4 to 10 billion years. Humanity has made significant discoveries in space thanks to the rapid development of astronomical observations and research. The objects and events that differ most from what we are accustomed to most excite the minds of Earthlings. Perhaps we shouldn't be modest. Frankly, terrifying things are a priority for many people. Among the list of such cosmic objects, a truly monstrous body holds a prominent place. The most dangerous star in the universe, a hypernova. Before explaining what it is, a small caveat. The nearest such monster is within the Milky Way, at a distance of 7,500 light-years, and its luminosity exceeds that of the Sun by a factor of 5 million. This is a colossal distance by human standards, but not so great that gamma radiation from the object's explosion wouldn't reach Earth. A hypernova is a cosmic body approaching the critical size limit. For a supernova to be considered a hypernova, its mass must start from 80 solar masses. During the collapse, the star's core releases a huge amount of energy, on average 10 times exceeding that of a supernova explosion. After compression, 3 scenarios await the star's core. It will become a neutron star, a quark star, or, most likely, a black hole. But that's not the most surprising aspect. The most deadly and stunning phenomenon accompanying the explosion is gamma-ray bursts. They can last from milliseconds to an hour and represent a powerful beam of rays that release in a few seconds the energy the Sun produces in its entire lifetime, 10 billion years. Fortunately, the bulk of the massive stars capable of such a spectacular death are located many billions of light-years from our galaxy. Moreover, space generates such monsters extremely rarely, approximately once every 200 million years. However, some astronomers believe that the extinction of most marine invertebrates that occurred more than 440 million years ago was triggered by a gamma-ray burst directed toward Earth. It's noteworthy that a hypernova star located even 3,000 light-years away could bring about total destruction to Earth, up to the annihilation of bacterial life. But in the Milky Way, a candidate for becoming a hypernova shines brightly, Eta Carinae. Until the 18th century, this binary star system was called the Argo-Novis. A massive blue hypergiant, containing about 250 solar masses, revolves in the vicinity of a smaller star with a mass of about 80 suns. In a few tens of millennia, it promises to demonstrate a spectacular end to its existence. The question is whether it will affect the life of our planet. Scientists claim that if a powerful hypernova explosion in the foreseeable future were to shake our galaxy, life on Earth could disappear forever. Although this is one of the most depressing scenarios, in the best-case scenario, the energetic echoes of the monstrous explosion would hardly affect our cozy planet due to the significant distance of the event. The first hypernova explosion, SN 2006 GY, was recorded in a very distant galaxy, located 240 million light-years from the Milky Way. This happened in September 2006. Besides the possible explosion of a cosmic body that generated a titanic energy gamma-ray burst, other versions of the origin of the observed anomalous brightness were considered, including the collision of 2 massive stars, antimatter interactions, or multiple explosions of the observed object. As already mentioned, gamma-ray bursts of unprecedented power are extremely rare. It's believed that only a few such explosions occur in one galaxy per million years. Their consequences are even more unpredictable and terrifying. It's important to understand that a potential hypernova in our galaxy represents a time bomb. This can be compared to the famous expression, a gun in the first act. If it hangs on the wall at the beginning of the play, it will certainly fire at the end. Will Eta Carinae, shining in the Milky Way, fire? Nobody knows, but considering its parameters, it's quite possible. One day, the last star will die, and the universe will plunge into eternal darkness. It is quite likely that a small red dwarf star, near which extraterrestrial life is most likely to be found, will become humanity's last home before the end of the universe. So, what do we know about red dwarfs and why are they our last hope? No less than 70% of the stars in the universe are red dwarfs, the smallest stars. Their mass ranges from 7 to 50% of the Sun's mass. They are not much larger than Jupiter, but they still have significant dimensions. They are also very faint. It is impossible to see them with the naked eye. You have never seen red dwarfs in the night sky. Even with the most modern technologies, we can clearly observe only the closest red dwarfs to us. About 20 out of 30 stars near Earth are red dwarfs. Like all other stars, they consist of hydrogen and helium. But while massive stars have helium in their cores, in red dwarfs, helium and hydrogen are constantly mixed, so they spin their fuel very slowly. Before they fade, red dwarfs burn so slowly that their average lifespan is 1 to 10 trillion years. For comparison, the Sun will live for another 5 billion years. Since the age of the universe is only 12.75 billion years, no red dwarf has yet reached later stages of development. Any of the trillions of red dwarfs is still a baby. By the way, about babies, the smallest star in the universe is also a red dwarf. Red dwarfs can barely be considered stars. If they had slightly less hydrogen, they would be brown dwarfs, failed stars that cannot sustain fusion reactions for long. So, what about aliens or a new home for humanity? Since the Sun will eventually die, we will sooner or later need a new home, and where there are habitable planets, there might be aliens. The Kepler Space Observatory found that at least half of red dwarfs have planets whose mass ranges from half to 4 Earth masses. Many of them are located in the habitable zone, the region around a star where water can be liquid. But since red dwarfs burn at relatively low temperatures, a planet must be very close to it, approximately like Mercury to the Sun, or perhaps even closer. This presents additional problems. For example, a planet close to a star may be tidally locked, meaning it always faces the star with one side. This side will be incredibly hot, while the shadow side will be extremely cold. This makes the planet very difficult for the development of any life. However, if we consider a planet with a large ocean, it could help distribute the star's temperature and energy, thus creating some stability. The red dwarf's gravitational forces could compress a planet and heat it to such an extent that all the water would evaporate fairly quickly. Consequently, such a planet could become like Venus. There's another problem. All red dwarfs release their energy differently. Star spots can form on their surfaces, absorbing up to 40% of the planet's light radiation per month. Consequently, oceans on some planets could freeze. Red dwarfs with star spots can also emit powerful solar flares that can double the brightness of these tiny stars for several minutes. This is enough to completely destroy large parts of a planet's atmosphere and gradually incinerate it. However, some red dwarfs could even be beneficial due to their longevity. Some red dwarfs with moderate activity levels could be unique and ideal places for life to continue in the universe. Life on Earth has existed for about 4 billion years, and we essentially have another billion years before the Sun heats up to the point where life on Earth becomes impossible. All inhabitants of Earth will either die or successfully leave in search of a new home. In trillions of years, we could build a civilization around a red dwarf with optimal conditions. Approximately 5% of all red dwarfs in the Milky Way could be habitable and have a size similar to Earth. The total number of such dwarfs is about 4 billion, but life may not need a planet like Earth. Around red dwarfs, there could be moons of gas giants, which can also be considered candidates for life. They are also called super-Earths, massive planets. Preliminary estimates suggest that there are about 60 billion potentially habitable planets located around red dwarfs in the Milky Way. Red dwarfs could indeed become important objects for humanity's survival in the future. But it's worth understanding that everything eventually dies, and red dwarfs are no exception. What will happen to a red dwarf when it dies? When, after several trillion years, the last red dwarf in our universe fades, it won't be a spectacular event. After the hydrogen on the star is depleted, it will turn into a white dwarf and gradually burn out completely. After the fuel runs out, the star will turn into a white dwarf, the size of Earth, made of degenerate gases, mainly helium. 4. Tightly packed together. As the dwarf loses its natural energy source, extreme cold will develop on it. The cold will kill the dwarf over several trillion years until it reaches its final form, a cold, black dwarf. White and black dwarfs are fascinating objects that deserve to be discussed in a separate video. In any case, it will take a very long time before all the stars in the universe disappear, which is encouraging, as humanity still has time to thoroughly explore the vastness of space and find the best solution to prolong its existence. You might think that the knowledge possessed by humanity is the result of technological progress and scientific research. That's not entirely true. On Earth, there have been, and still are, wild tribes that learned about space and the laws of the universe long before us. First and foremost, we are talking about the mysterious Dogon tribe. Their habitat, the Bandiagara Escarpment, is located on the African side of Mali. Nobody knows where the Dogon tribe originated in the plateau region. The Dogon are almost completely isolated from the outside world, so they were only discovered in 1931 by the Frenchmen Marcel Griaule and Germain Dieterlen. These anthropologists lived with the tribe for about 10 years, observing Dogon life in all its manifestations. This ethnos, numbering about 200,000 people, is quite primitive. The Dogon live in caves or mud huts, cultivate fields sown with sorghum, and love ritual dances. The anthropologists' decade-long stay with the tribe resulted in a scientific work that did not immediately attract public attention. But when these records fell into the hands of Robert K.G. Temple, an English astronomer, the world looked at the Dogon differently. The first thing that amazed the scientist was the fact that the Dogon were fully aware of Sirius, a star that was only officially discovered by science in 1862. And there's more. Here are just some facts known to the Dogon tribe. These people know all about Sirius, the brightest blue giant and the closest to our solar system. Its luminosity is 22 times that of the Sun, and it is located 8.5 light-years away. The Dogon have long known that Sirius is not alone. There is also Sirius B, a white dwarf whose density is 1.5 million tons per cubic inch. Sirius B revolves around the main star of the Sirius system, Sirius A. One revolution takes about 50 years. It's impossible to see the white dwarf, like other stars in this system, without special equipment, let alone determine the period of their revolution and composition. Moreover, all Dogon rituals are timed to this 50-year cycle. As for our home, the solar system, the Dogon know a lot about it. The records of the French anthropologist who lived with the tribe for a long time document an interesting fact. A Dogon elder once drew a map of the starry sky with Sirius as the center directly on the sand, and he didn't make a single mistake. The tribe has long known that Earth revolves around the sun, and their calendar, like ours, is divided into 12 months. The Dogon themselves claim that a long time ago, aliens arrived from the heavens who could only exist in water. Therefore, liquid splashed inside their helmets. These beings were called Namos, meaning drinkers of water. They claim to have come from the star system Sirius and shared unique knowledge with the tribe. Incidentally, more than 12 cultures in the Mediterranean alone are based on similar legends. Drawings illustrating these traditions are found in the Dogon country, in the deep cave of the Bandiagara escarpment, guarded around the clock by the tribe's holy elect, specifically for this mission. The rock paintings in this cave are more than 700 years old. The Dogon, among other things, claim that in the land where they lived before, there is a repository of material evidence of the Namos' presence. Skeptics argue that the Dogon acquired their knowledge either from the Egyptians or from missionaries who visited Africa at the beginning of the 20th century. But Egyptian civilization perished before the explosion of Sirius B, which occurred in the 2nd century AD, and the Dogon possess information about this large-scale event. Regarding the missionaries, if they had taught the Dogon, they would have mentioned Jupiter's 4 Galilean moons, known in the 20th century. They wouldn't have known about the 4 moons of Jupiter or the structural features of galaxies. Even today, among the tribes that amaze scientists, the Dogon, Aztecs, Sumerians, Maya, and Inca civilizations, long vanished from the face of the earth, hold a special place. This wild people lives on, astonishing with its knowledge, incomprehensibly found in the heads of primitive natives. The death of giant stars. What could be more epic and impressive? But do they die completely? Does something even more surprising and incomprehensible remain in place of the Titanic star? Until recently, such stellar remnants were considered messages from unimaginably distant civilizations. However, let's proceed in order. First, let's recall information known to Earth's astronomers about the death of stars several times larger than the Sun. After an unprecedentedly powerful explosion, in a fraction of a second, the star sheds its gaseous shell into the dead vacuum, and its core instantly collapses into a tiny object insignificant compared to its initial parameters, consisting of protons and electrons glued together. The new constituent of the star's remnants, neutrons, gave the object its name, a neutron star. It is not just a stellar corpse, but something intermediate between a star and a black hole. If compressed further, A neutron star would collapse into space and turn into a dark universal monster that devours everything, even light. But that's not all that is interesting and surprising about a neutron star.